Now we will see the last question in the atomic structure, that is electronic configuration. This question reads as the electronic configurations of three elements are given. EU means europium, all are synthetic elements, F block elements. EU is europium, its atomic number, within bracket atomic number is given. Atomic number is denoted by the letter capital Z. So europium with atomic number 63, GD gadolinium with atomic number 64, and TB terbium with atomic number 65. Their symbols are written for these elements: europium, gadolinium and terbium. So atomic number means number of protons or number of electrons. Now we are bothered about the electronic configuration. So the system contains respectively europium contains 63 electrons, gadolinium contains 64 electrons, terbium contains 65 electrons. All the electrons will be outside the nucleus. So they have to be, all the electrons have the same charge. Each electron will repel one another. So it has to be properly positioned. That describes the electronic configuration. Here the electronic configurations are written in terms of the nearest inert gas. So the inert gases are helium, neon, argon, krypton, xenon, radon. Xenon electronic configuration, the xenon atomic number is 54. So all these elements have the atomic number higher than 54, which means that up to 54 xenon configuration is repeated for any element. So it is written, the electronic configuration can be written in this form also, instead of writing every time 1s2, 2s2, 2p6, starting from every time. Instead of nearest inert gas configuration will be repeated. Xenon means, so xenon atomic number 54. If you add plus 54 plus the power, here it is not actually the powers. These denote the number of electrons in the respective orbital. 4f orbital contains 6 electrons. 5d orbital contains 1 electron. 6s orbital contains 2 electrons. Here you got to bear it in mind, xenon 54 electrons. So 54 plus 6, 60, 60 plus 1, 61, 61 plus 2, 63. That is its atomic number. So in this way it has to be, it is arranged. But anyhow, 4 choices are given. The electronic, here the electronic configurations are, the question is the electronic configurations of europium, is that equal to 63, gadolinium, is that equal to 64, and terbium, is that equal to 65, or 4 choices are given, but only one choice is correct. It is a multiple choice question. So only one choice is correct. Which choice is correct, we have to identify. So as you look, all of them will appear to be correct, but here we have to follow the rules to write the electronic configuration. Aufbau principle, Hund's rule of multiplicity, Pauli's exclusion principle. Aufbau principle states that electrons tend to fill in the increasing order of energy level. So in the 1s, 2s, etc. up to 3p regular. Afterwards 3p, next to 3p, next level, higher level is 4s. Then only comes 3d. 3d level, even though inner, its higher energy content is higher. So as per the Aufbau principle, 4s level is of lower energy compared to 3d level. Similarly, 6s level, 6s is the outermost orbital, 4f is the innermost orbital, middle one is inner orbital. So here inner orbital energy is maximum, 5d is maximum, outer orbital energy is minimum. That is to be noted. 6s energy level less than that of 4f and less than that of 5d. What is the significance of this level of Aufbau principle? So here electronic configuration has to be written, or electrons tend to fill up in the increasing order, means that if you write in terms of energy level, first 4s, then 3d, first 6s, then 4f, then only 5d. So this is the increasing order of energy level, but you should not confuse with these numbers. 6, 4, it may appear as though 5 is the topmost. It is not like that. 5 represents the inner shell, 4 represents the innermost shell, 6 represents the outer shell. Outer shell has the lowest energy. So If you up to xenon, it is correct. Xenon means 54. Up to 54, it is correct. What happens to the 55th electron to 63rd electron or 64th electron or 65th electron? How they are getting filled? That is to be noted. Everywhere also 4f, 5d, 5, 6s, 4f, 5d, 6s, 4f. So in some cases 5d is not there. That is to be noted, which is to be identified. Here in this way, first 6s is to be filled. So first one is europium, 63 out of 63, 54 have been filled. Remaining 9 electrons. 9 electrons, next to xenon, 6s has to be filled. 6s 2. 54 plus 2, 56. Balance 7 electrons. 7 electrons go to next higher level, 4f level. So f orbital, 7 types of orbital, they tend to remain unpaired. The Hund's rule is also to be followed. So in this way, it is correct. 6s and 4f. 5d orbital will be there, it is empty. 5d orbital is there, but it is not filled with electrons. This is the case of europium. Next, coming to gadolinium. Similarly in the manner, for 6s and 4f have been filled. The question may arise, half filled, next filled. Half filled, they tend to remain unpaired, innermost shells. So innermost shells means they tend to remain unpaired. Next to 4f, it will next electron will not go to 4f, 8. Then because 6s have already been filled, 5d, next electron goes to 5d. So 63rd electron, up to 63rd electron we have filled. 64th electron go to 5d orbital, the 5d1. That is the correct electronic configuration of gadolinium. Lastly, Tb, capital T, small b. Tb means terbium, T-E-R-B-I-U-M. Its atomic number is 65. So 65 minus 54, 11 electrons are there. 11 electrons, 6s have been filled. Then comes to 4f, 9. So 11th electron also, when it comes to the case of 11th electron or 10th electron only, the f orbital is getting paired. Till then, f orbital will not be getting paired. Here simultaneously we have to follow the two rules of Bohr principle. That is the increasing order of energy level, then off-field configuration. Because off-field, what is meant by off-field configuration? F electron capacity is 14 electron. 14 by 2, 7. 7 is half-field. It tends to be remain half-field is the most stable. That is why 4 of 7. So there is no 4 of 8. It will not. 4 of 8 in some it is given. 4 of 8 it is given. We will be tempted to write 4 of 8. 4 of 8 will be rearranging to get 4 of 7 and 5d1. Whatever be the case, that is to be noted. Because of the higher priority of off-field configuration, first 4f is getting filled. So as per this order, choice C is the correct one for this electronic configuration. Others are not there. 4 of 8 means it is not off-field. 4 of 8 is not off-field. That is to be noted. F means it is 7. F capacity, 7 types of orbital. 14 is the completely filled. 7 is the half-filled. Half-filled configuration preferably it takes. If it is not possible, it takes to 4 of 9. That is to be noted. That is the idea. So others you can leave. So they will give in this manner. We will our general expectation is that 54 minus 11 as per our wish we write. It should not be the case. We have to be followed. So we need not bother about whether 5d is getting filled or 5d has no electron. No botheration in that. Our aim is to have the stablest system where half-filled configuration is the most stable. F electron system 7 is the most stable. These points are to be noted. As to following these points, choice C is the correct configuration. We have to patiently approach the system so as to arrive at the choice. Wherever it is it XE, 4F, 5D, 6S like that. You have to first segregate, first 54 electrons segregate as xenon electronic configuration. Then what happens to the remaining 9 electron or 10 electron or 11 electron? So So for this filling up 9 or 10 or 11 electrons, you got to bear it in mind the two rules, that is Hund's rule of multiplicity as well as Aufbau principle, that is to be noted. This is with respect to the electronic configuration of heavier elements, higher elements. So generally electronic configurations of higher elements are reported in terms of nearest inert gas configuration. Instead of writing from the starting from the top, starting from the beginning, you cannot write 1:1:2 in this way. Here itself it takes the longest chain. So it every for 63, for 64, for 65 you have to write like a paragraph. It should not be the case. So it is better to condense in the form of nearest inert gas configuration.